the cells of the lymphatic system. We have what's called natural killer cells, also known as NK cells. Look at what they are. Large lymphocytes. One of the types of cells from the bone marrow. Okay? They're large lymphocytes. They have become infected with either viruses or they're cancerous. Okay? They want to try to kill those types of cells.
Who's that?
The natural killer cells.
They want to kill what kinds of cells?
They want to kill cells that are going to have viruses in them or cells that have turned cancerous. Now the problem is, because they have become infected themselves, they have to die also. But in dying, the substances they secrete hopefully will kill the other cells or have other cells around them produce a defense against the virus or the cancer.
Is that how, like, flu shot? Is that like the flu shot works?
Not really. The flu shot, what it's going to do, most likely, it's going to introduce the virus to your system. What they try to tell you is you're not even going to know that you got the shot, okay? But, I don't agree with that. Now, what happens is they have introduced a pathogen into your body. The goal that the immune system is going to mount an attack. Anytime the immune system has to mount an attack against a pathogen, it's going to use T cells and B cells, and it will create a memory. The cells that have created the memory are the ones that if you were to get, let's say they gave you, because when you get the flu shot contains 3 viruses. It's going to have the one for in other words, every time you get the shot, you get those same 2 flu viruses. I just can't remember the names of them.
Are you saying like the strand?
Yeah, the strains.
I thought they changed the strain.
The only one they change is the
third one. Okay.
Okay. The third one is the one that they're going to be predicting will be the most prevalent for the upcoming flu season. But see, there could be 10 strains that are out there. You've only now been inoculated against 3. And you could get sick with the flu from any of the remaining 7.
Yeah, like a couple years ago, they totally got it wrong, and everyone got sick.
And everyone got sick. So the goal is to basically take and activate the T cells and the B cells. And what these do, when you call up these cells to fight a pathogen, they create a memory cell. And if you were to be, let's say, of the 3 that you got in the shot, I don't know, you touch the doorknob, and then you wipe your nose or your eyes, or you go eat or whatever. And because that what you consumed from touching the doorknob was part of the 3, you're not going to get sick. But if you touch the doorknob and it was one of the remaining 7, You eat, touch your face, wipe your nose, scratch your eyes, or, rub your eyes or whatever, and it's now one of the remaining 7, you're going to get sick. And then you're going to be like, well, wait a minute. I took the flu shot. Why did I get sick? Do they tell you that you're only getting inoculated against 3?
So does like somebody that just like some people have weaker immune systems and some people have stronger immune systems. Does that have to do with like solely like these B cells? Just
Yeah.
so that would what would that mean? They just have like a lot of.
There could be a lot of things that could go wrong. There could be other medical conditions that have weakened the immune system, and they just don't have the cells available to fight the attack, and they get sick. It could just be that maybe their diet is not correct. There are lots of reasons why the immune system may not function correctly. Lots of reasons. Yeah. Determining what it is, that's the tricky part.
Is there like any way that they could like give you the like 3 strands and like say your body's like fighting off something else for it to like activate those cells, like then not your cells not like fight off them? Does that make sense?
So in other words, if you took the shot and you get sick with one of the other strains, could they do something to help your body boost immune against that strain?
No, like what if your body was already fighting off something else and then you got the flu shot? It's like, could you get sick from those 3 strains?
Yes.
Okay.
Yes. And people can actually get sick from the flu shot. They tell you no, okay? I don't care what they say, you can get sick.
But it's
From
not a
flu
live
shot.
virus.
It doesn't matter. You have still
You're getting
injected,
like an
you have
immune
injected
sickness,
that
but-
virus into your system that is and they want it to mount an attack. And if it mounts an attack, and if it does it in a way that it's recognizing that pathogen as being a true breach to its body, you are going to get sick.
But not with the flu.
Yes, you are going to get sick with that virus. Yes.
Well, I was going to say, your body is mounting the immune response, so you have the signs and symptoms of being
Right,
sick, but
that's
because
what
it's
I'm
not
thinking,
active, it's
yeah.
not like it's going to continue to
But you
replicate.
have, see what people do not, okay, this is just what, okay. For a virus, note my terminology, okay? Virus. A virus is dead no matter what you do. They're going to tell you they are inoculating you with a dead strain. Of course they are. Because the virus on this table right here is dead. The virus on that doorknob is dead. The virus on this handle for the water is dead. But the second it gets introduced into my body, I have given it a host.
Why did some people get sick and just because the way their body may fight it off, some may not? Like some people don't feel any effects.
They may have already been exposed to it, gotten sick by what they have been given in the inoculation. The body has already the resistance to it. They're not going to get sick. Once you have fought the virus, okay, once you have fought the virus, the body's mounted the attack, it has created the memory cells, you are not going to get sick with it again. And if they use the same strains over and over and over, you've already mounted that attack once.
I have like a question about.
I just don't understand. I'm
But
like,
not with the third, right? Because there's antigenic
And the third
drift
changes.
and antigenic shift
But
where
they
it
are
changes
only-
every like 10
but
years.
they're only going to change the third one every so often. In other words, you get the flu shot this year, they might be using as a third strain what they used 5 years ago. And if you didn't get the shot 5 years ago, you're now getting it introduced, and you run the risk of getting sick.
Well, okay, so in life, if we're exposed to certain viruses and we don't get sick, it's kind of like a mini flu shot in a way, right?
All right, women, do what?
Well, I know it sounds,
Yeah.
it's strange.
Yes, that's what it is, yeah.
So then that's why, like,
Wait a minute, will you
when go
repeat
to
what you
different
said?
countries- Okay, like, when you're exposed to, say, any sort of virus, but you don't get sick, it's kind of like a mini flu shot in a way, because you're exposed to that, you get the T and B cells to remember that. And would that explain why, like, say somebody goes to a different country, and they'd be more prone to get sick with those kinds of viruses because they've never really been exposed? Does that make sense?
And our chances of that, now, what'll happen is if you're introduced, like if something that you have done introduces you to a new pathogen that your body hasn't recognized, what the body can do, the body will first use general defenses. Now, what does that mean? General defenses are the same no matter what. Okay? Doesn't matter what the pathogen might be, virus or bacteria. Okay? The thing that gets me is understanding the distinction between the two. They are not the same. Okay? Now, at first entry, the action from the body is the same, no matter what. If that general defense handles the pathogen, most likely you don't even know it. But note, it was only the general defense. No memory cell got created. Okay? If the body has to call up specificity, which will be true immunity, you will have some type of signs or symptoms, okay? The difference is your body handled it, you only had a little bit of an issue, okay? When your body cannot handle, now it will create a memory cell from specificity. When you're invaded by something, your body cannot handle, no matter what it does, to mount an attack against it. That's when you get really sick. You might need some help from medications, fluids, other stuff like that. But at the same time, your body does create a memory cell for that. And if you're exposed to it again, chances are, it's not always, chances are you won't get sick again.
Only memory cells are only made from T and B, not natural killers.
Not natural killers.
Okay.
Only from T and B. Our T cells. Now, if you remember from chapter 18, these are the cells that make their way to the thymus gland, and that is part of our endocrine system, and the cells are exposed to the hormones of the thymus gland, and they become T cells. Now, the B cells, and it's a really cool story about how these were discovered. So read this in your textbook, okay, because it's really cool. But these are going to mature in our bone marrow. They're created and they mature there. Now, their job, they can be in connective tissues and they can be called up when the body needs specific immunity. T cells and B cells work together. for the most part, okay? Another type of cell of the lymph system, macrophages. Macro meaning large, phage meaning to eat, okay? So, for the most part, these are going to be large cells, hello, macro, phagocytic, meaning to eat, okay? And for a lot of their purposes, they're going to be in connective tissue. Now, with those, okay, do you guys remember the monocytes?
Mm-hmm.
Okay, so macrophages, they will develop from monocytes that are moving around in the bloodstream. Now, here's one of the things that these cells can do. If they're in the bloodstream, and if they can move into the connective tissue, and if they can encounter the foreign pathogen, and they say, you know what, there's not enough of us for our general defense to fight this pathogen. I need to call up my T cells and my B cells. So they will actually take a piece of that foreign pathogen that they're trying to fight off. They'll actually take a little piece of it, ingest it, push it through its own membrane, and they have now become an antigen presenting cell. They are now going to make their way to a lymph node. All right, think about this for a second. Something has breached our body, okay? An opening of some sort, so to speak. Let's say a cut or something to the outside of our body. Our body doesn't like that. It has all of these actions that it will do to try to fight off anything that tries to make its way in. Okay? So, in the process of this happening and my repair that has to occur, okay, cells have made their way to the site. Some of those cells are the macrophages. And let's say that there are too many bacteria trying to enter my system now. All right, one of those macrophages will say, whoa, this is just too much. So it'll attack one of the bacteria, ingest some of that bacteria, take it and begin to move towards a lymph node. It wants to make it to the closest lymph node, okay? So it'll start moving its way to the lymph node, and it'll begin to push some of that bacteria that it consumed, okay, onto its own membrane. And when it gets to the lymph node and encounters the T cell, it will go, we need help. And T cells go, oh, cool, okay, let's go. All right, and then we have now mounted an attack. And this is going to be specific.
And that's where your lymph node would swell.
This is when lymph nodes would swell. And this would be, most likely, you're going to get a little, you're going to start feeling different symptoms, okay? And then those cells are going to go through all of these different processes. They're going to duplicate, they're going to make copies, and we're going to have T cells and B cells making all these different cells, and they're going to rush to the area, try to fight that pathogen, and be like, okay, whew, that was a close one. We won that war, won that battle, all right? And in the process, a couple of those T cells, a couple of those B cells made some memory, and if that ever tries to invade you again, they mount the attack and you don't even know it. So these cells become what we call antigen presenting cells, APCs, because they are presenting some of that pathogen the body needs to fight. And that will be specific. Take a break. Be back in another.